Hey, on this video, we are going over question 13 from your study guide. In this question, we've got a ball falling from rest from a height of 8 meters, and it's going to fall for 5 seconds. Then I give you acceleration due to gravity. That's negative 9.8 meters per second. I'm not going to lie to you, I technically kind of screwed this one up. For the most part, you can solve everything, and on the test, I will not make this mistake. I apologize for that. So let's get going with this. We're going to first start with sketching the position time graph. And when I say sketch, what I'm looking for is the right shape of line, the right placement of the line, and key numbers. You don't have to label every single number that's going on. You just the important ones. So for this position time graph, we know we're going for 5 seconds because that information is given to us. And we know we are falling for 8 meters. So we're going to start up here at 8 meters and then fall down to 0 meters. Now, technically, if you started at 0 and fell down to -8, that would also be technically correct. And I would count that correct on the test. So we're going to draw this now. When you are falling from rest, you are speeding up as something falls and you drop it. So we're going to have our curve show that as well, like this. So that's it for the position graph. For part B, we want to sketch a velocity graph. And again, we're looking for key numbers here. We know it's going to go for 5 seconds. That information is going to be the same. And we know it starts from rest. So that means our initial velocity, it's going to start from 0. And then we're going to go, we're speeding up in that negative direction. So that means our line is going away from the x-axis. But where does this end at this bottom part? That's what we don't know yet, and we're actually going to answer in part D. So if we want to skip ahead real quick to part D, we want to know how fast it's going just before impact with the ground, which is technically called its final velocity, and we'll learn more about that later in the year. And the way to solve this, technically there's 2 ways depending on the information you have. You can either use the slope of the line, which is what I screwed up. Technically, I gave you what the slope should be. However, I gave you a number that doesn't work with the other numbers to be correct. So the other way to do it is what you're going to need to do in this case. And if I didn't give you the acceleration, this is what you would do. You would find the area, you would use the area of this triangle here to find what you want. So we have the area here. We know this area, what it's going to be, and it's going to be 8 meters because that's how much it fell from a height of 8. So it would be your area is 1/2, since it's a triangle, times the width, which we know is 5 seconds. And we don't know the height here. So I'm just going to leave in a V for velocity, and that's going to equal our area, which we know is 8. So now we can solve for V, so 1/2 times 5 is going to equal 2.5 times V equals 8, and then divide both sides by 2.5. And when we do that, we are going to get an answer of 3.2. And that will be in meters per second. So that's technically question D, and then we go back up here, and I'm going to write it on my graph. And it is going to be, I'm sorry, this should have been a -8. I messed that up. -8 because it is below your x-axis, so it'll be -3.2. So again, our area, it's falling from a height of 8 meters in the negative direction. So it would be -8 should be our area. So make sure you include that, and you don't mess it up like I'm doing right now. All right, last one on this set is to draw your acceleration time graph, and this one is an easy one. So your acceleration time graph. Now, technically, this is kind of also where I messed up. I gave you the acceleration rate, so you can immediately go in and draw this graph without doing anything else. It would be 5 seconds, and at -8 meters per second, that's the acceleration rate I gave you. That's what I was looking for. However, I messed this up because what I failed to do properly was make sure this acceleration rate of -9.8 should also be your slope right here. And it does not work out that way to do it, because if you calculate the slope here, that's not going to equal -9.8 like it should. So properly worded questions will make sure that your given acceleration rate, if it gives you one, will match the slope here on your velocity graph. So I will ensure that mistake is not made again. So anyway, that's it for question 13. If you still got questions about it, just let me know and I'll be happy to help.